Okay, so welcome to example problem 5.2.4, the Mahalco method. Don't go looking that up. It's kind of a joke. Uh, when I asked the class which side that you all wanted to distribute, it was suggested that we distribute the left two, and of course I was like, no, 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 no. I am the sage on the stage. I shall guide you, and through the power of my magic, which is surely beyond your comprehension, you shall learn, right? And that, of course, didn't work out so well. At any rate, that said, do be careful when you're combining like signs. Usually it sets up a situation where you just flop signs, and where you just flop the operators back and forth. We've seen that a number of times. However, in this case, it worked out very well because the opposites, as was also suggested in that same moment, the opposite B's here uh, cancel into one, leaving a very happy C and 1, which just became C, and everything worked very elegantly after that. And we'll see that. I'll go through a couple of different, well, I'll show you both ways of approaching it, basically, and then we'll just work the better way, which wasn't the way I worked in class this morning. Okay. So looking at that first way, so if we pull the A out on the left hand two components here, we get A and, because our minor sign becomes our major sign, A and B, or B and C, or not B and C. So B and C, or not B and C. Okay. And this, of course, is all one happy term because I distributed it, leaving just the rest of the statement, the rest of the proposition or equation, expression to be written out here. Okay. Excuse me. Now you can see when we distribute this out, and we'll pull the C's out, we get a happy C. The C's collapse and leaving a B or not B, which collapses into a 1, and etc. When I did it by pulling the left two out, and we'll look at that really quickly here. I'll make that just kind of in another color. Maybe we'll do sort of a more of a red or an orange or something. Yeah. When I did it, so for like line 3, I pulled out these left ones. So we had A and B and C. And the reason, of course, I pulled out the left ones is I have two opposites here, and I just really thought it would work out fairly well if we, stuck more with the opposite side. So, at any rate, or, and then we pull the A out, so we get A and B or C, B, not B and C, A and not B and C, or A and B and not C. So that works out as A and, this is going to be the big term over here, B and C right here. Or is now, so the or is now joining our last two proposition together, is now the minor term because this is the major term. That and is, okay. B and not C. And look again, I once again forgot my, okay. This, of course, is, both these are 1 by distribution. This also is 1 by distribution. Okay. So looking at this, you can see when I pull the B's out, like I said here, I get the C's come out. Sorry, I pull the C's out, and the B or not B collapse into a 1. Here, I can't pull either of these out. So I ended up, whatever, however you want to look at that, as distributing this through, which made a very big problem. Not like an, oh my gosh, it's a problem, I don't know what we're going to do, but a very big expression. Any rate, so not the way to go, really. Live and learn. Usually picking on the, most of the time picking on the opposite sides gives you a really good deal. Here, having one opposite with two of the same worked out very well. So next time you see that, maybe you might give it a try. All right. So line 4, we're just going to move on from line 2, leaving line 3 alone. And you can do that. You don't have to move directly from line 3 into line 4. That's usually how it works, that line 4 is derived from line 3, but you don't have to. You can derive something different from line 1 and put it down there. It doesn't matter. It's all good. So I'm just going to step back to line 2 and finish this method. So we're A, and we're going to pull the C's out. I'm just going to go ahead and do it in this direction, even though technically that's not right. So I'm going to count it as a commutation, flipping them, and then pulling the C's out. So 2 commutations. All right, let's see. So I have, so it's C C and B or not B. C and, so our minor sign becomes our major. B or not B, and the major sign is now the minor sign linking the 2 extra terms or in terms or last terms or whatever you want to call them. So we have that there, and then the rest of the statement. A times, or A and B and not C. This, of course, happily, as we predict, that's by 1 or 2 by distribution. And as we said, this happily collapses into A and C and 1, or A and B and not C. From line 4, by complement, C or C and 1, of course, the 1 just drops off, or C or 1 is, of course, C, however you want to look at that. I like it's technically C or 1, C and 1. C and 1 is C. So we have 6, A and C, since that's since that's a conjunct, I'm going to go ahead and put it in, group it together to remind myself. And, sorry, A and B and C complement. Okay. Now I can pull the A out. That's 1, that's from line 5 by identity, I believe. I don't have my rule sheet in front of me. I apologize if I get these wrong. Okay. Now I can pull this A out via distribution. So A and our minor sign becomes our major. A and C or B and not C. So our last 2 terms get linked together by our erstwhile major operator. So C or B and not C. Okay. Happy. Let's see then. And of course, once again, we get the opposites, the C and the not C, which will go ahead and cancel out to 1 when we distribute it. Oops, this is from 6 via distribution. And then line 8, opposites are going to pair up. So, okay. A and C or B. And C or not C. From line 7, by distribution. Of course, the C or not C here will cancel out to 1 through identity. So, and that will leave just, and then it will drop out. Sorry, cancel out to 1 through complement and then drop out through identity. So I'm just going to put those all in one line. Maybe I'll put them on 2. 9 becomes A and C or B. Nope, don't need that. And, well, yeah, I kind of do. And 1 from 8 via complement. And then that, of course, that 1, any term of P and 1 is, of course, just P. So we can go ahead and on line 10, reduce this one more time or simplify this one more time to A and C or, wow, let's just forget writing things down. A and C or B from line 9 via identity. And that is how that problem is worked much more efficiently. What we did in class was not, I'm trying to remember we ended up here. The direction we went by utilizing the right to components or expressions, it wasn't wrong in any way. It was just less efficient and turned into kind of a mess. So, okay. I hope this helped. Thanks.